Welcome. My name is Hans Smola. I am the Medical Director of Paul Hartmann. My task is to provide scientific and medical evidence. And the topic today is the topic of epithelialization. That's a process that's the ultimate goal of wound healing, to re-establish the epidermal barrier and to re-establish the barrier function of the skin. Now, how does epithelialization work? Epithelialization starts from keratinocytes at the wound border. So these cells, they migrate towards the wound center. And they get their cues for migration from the underlying connective tissue. So cells in the connective tissue send out signals that tell the keratinocytes to migrate into the wound center. And these signals are growth factors. And growth factors that are being produced by the underlying connective tissue cells. These growth factors diffuse to the keratinocytes, and that's the cue for migration. Now, is this process important? Of course, from a biological point of view, it's the most important process. But we were surprised from a survey we performed during the 2015 EUMA Congress with clinical specialists. We asked them, is epithelialization a neglected topic? And we were surprised. 70% of the respondents told us that epithelialization is a topic that is neglected, a topic that does not get the attention it deserves. It turns out that there are not many conservative procedures that can do this. And in fact, we identified that this is a clinical need. We don't have any procedure that works outside of the operation theater. And what we came up with is that we selected macromolecules, polyurethanes, hydrated polyurethanes, because they have unique properties. What they do is, from complex solutions, they are drawing out the water, they are absorbing the water, and they are leaving behind the growth factors. And since the volume is smaller, the concentration of the growth factors in the remainder is much higher. And you compare this very easily to a very simple experiment. If you take 2 cubes of sugar and put them into a small espresso cup, it will taste very sweet. If you take the same 2 sugar cubes and put them into a long Americano, you will see it's also sweet, but not as sweet as the small espresso. So concentration simply means that you have a substance in a volume of fluid. And these hydrated polyurethanes are able to concentrate these growth factors in complex fluids like wound exudate. Now we did in vitro experiments to show and quantify, does this lead to faster epithelialization? And the test that we selected was that we used petri dishes with keratinocytes, confluent petri dishes, so the whole petri dish was covered with keratinocytes, and with a sharp object we were incising, we were scratching the surface so that an epithelial defect starts to appear. And you can measure within a time period how fast are keratinocytes closing the defect. Very quantitative, very easy to measure. And when we added growth factor, we saw an immediate effect that the epithelialization was faster. But if we treated the growth factor solution beforehand with these hydrated polyurethanes, we observed that wound closure was much faster. So it's a very good indication that concentrating growth factors with these hydrated polyurethanes is an effective way to stimulate or boost epithelialization. Now, one critical question is, does in vitro relate to in vivo findings? And we used, again, a very standardized experimental model in pigs, and that is split thickness donor sites. Very thin, very superficial epithelial defects. And you can measure how much time does it need, or in which time does the epithelium migrate towards the wound center. And you can compare it. And what we did is we either used a hydrated polyurethane interface, or we used something that's completely inert, does not have any biological effect, and that would be a silicone dressing. And when you do this, it's very obvious from these pictures that you see that the epithelialization was much faster when you use the hydrated polyurethane versus the inert silicone. Much faster means in a system that is already optimal. So to stimulate and boost epithelialization, it really needs to have a very strong and effective mechanism behind it. I think this is a very interesting model, a very interesting opportunity to speed a process which in the past we could only treat in a very passive way. Either epithelialization happens and we can't do anything about it to boost it, or now we have an opportunity to boost it, to speed it up, to fasten it, simply by this model that we have a technology behind it that concentrates the growth factors that are there and boosting their activity so that the biological process can proceed faster. I think, from a clinical perspective, this is an attractive option. Thank you very much.